Okay, greetings guys and welcome to another lesson. In this lesson we are going to be looking at two very important rules, the sine rule and the cosine rule. So after this lesson you should be able to understand what is the sine rule, when do we use it and how do we use it, and you should also understand what is the cosine rule, when do we use it and how do we use it. Okay, so as a starting point, let's jump to something which you are very familiar with, which is called the Pythagoras theorem. So one thing I need you to remember from your early years, I think from grade 10, you should remember that we use the Pythagoras theorem when we have a right angle triangle. That is very important. And the obvious question which we ask ourselves here, just to remind some of you, is what is a right angle triangle? If you remember, a right angle triangle is a triangle that has 90 degrees as one of the angles. What is this? So I'm just going to paste a typical triangle. So a right angle triangle would be a triangle that has one of its angle as 90 degrees, like this one. So that angle C, it being 90, makes this entire triangle which we have to be a right angle triangle. This is the kind of a triangle where we are allowed to use the Pythagoras theorem. And if you remember, the Pythagoras theorem says that our hypotenuse side squared will always be equal to our adjacent side squared plus our opposite side squared. And remember that your hypotenuse is the side that is the longest, which is always opposite to 90 degrees. So that hypotenuse would be the yellow side. And the adjacent and the opposite depends from where you are looking at. So for this problem, we have a side which has length B, another one which has length A, and the other one, AC, has length C. So according to the Pythagoras theorem, as you can see, our hypotenuse is C. So the equation that would work would be C squared would be A squared plus B squared. This would be us using our Pythagoras theorem. So if we're looking for A, we can easily make A the subject of the formula. So you can have A squared and transpose the B and have A squared will be C squared. If you look at the transposing, minus B squared. And if you're looking for B, you will see that your B squared will be our C squared minus A squared. And furthermore, if you now look for A, you can just take the square root of the other side. So A will be the square root of C squared minus B squared. And if you're looking for B, remember you're not looking for B squared, so you need to take the square root. So on the left hand side it cancels, so we'll have C squared minus A squared. So the Pythagoras theorem works when we have right angled triangles. That is what we have here. So that 90 degrees there makes this thing to be a right angled triangle. So now with cosine and the sine rule, it comes when we do not have right angled triangles. So what happens then? But before I even jump to what happens when we don't have a right angle triangle, I would like to remind you of a couple of things, which is that if we use the trig ratios, let's start with sine of A, sine of angle A. So maybe what I need to remind you is that whenever we are looking at sine, as a ratio, we're looking at the opposite divided by the hypotenuse. And when we're looking at cos, as a trig ratio, we're looking at the adjacent side divided by the hypotenuse. And you'll see what I mean. And when we look at tan, your mind should remind you of the opposite divided by the adjacent. Okay. So we need to be careful what we mean by opposite and adjacent, because this changes depending on the angle which we're looking at. Okay, so let's start off maybe by taking a very simple angle. Let's take tan or sine of B. sine of angle B. So sine of angle B, if you remember, sine is opposite. So if I'm standing here at B, I will look at the opposite side, which happens to be that B. So I'm looking from angle B, the opposite side happens to be B, and the hypotenuse is always the longest side, which is C. And if I go and look at cos of B, I am still at B, but now what I need to look at is the adjacent side to B. So what is adjacent side to angle B is that one, which is A. So it means cos of B, remember, is adjacent over hypotenuse. So what I will have will be our A divided by our C. And then we go to tan. So let's take tan of B. So remember that tan is given by the opposite divided by the adjacent. So since we're talking to B, I should look at opposite of B. I have side B divided by the adjacent side. When looking from B, that becomes A. So that becomes tan of angle B becomes B over A. Now let's go to A. Let's have a look at sine of angle A. So be reminded that sine is always opposite over the hypotenuse. So when I'm standing at A, which is here, angle A, what is the opposite side? If you look at the opposite side, it becomes A. So I'm going to have A divided by, the hypotenuse is always the longest side, it doesn't change, divided by C. Hope that makes sense. And then we look at cos of A. When I'm standing at A, which is here, what is the adjacent side? So that one is opposite. So clearly the adjacent is this one, which is B, divided by the hypotenuse, doesn't change. It's the side opposite 90 degrees. So that is C. Okay. Then let's go for tan of A. Angle A, remember tan is opposite over the adjacent. So when I'm standing at angle A, opposite side is A and the adjacent side is B. So that is what we get. Tan of angle A is simply side A divided by B. And you can now easily find the angles. Okay. This works out very well when we have a right angle triangle. But what happens when we don't have a right angle triangle? That is where sine and cosine rule come in. So let's have a look at that at the next page. The question on the screen is very important. What happens when the triangle is not right angle, meaning there is no 90 degrees as we had with this one, where we can use the Pythagoras theorem to find the length of the side, so we can use the ratios to find the angles. So what happens when the triangle does not have a right angle triangle? We are left with two options. Option number one, we are going to use sine rule. That is what will happen. Option number two, we'll use cosine rule. So now we'll jump into the details of when do we use these. So what I'm going to start with the sine rule. And the most important question which we need to ask ourselves is, when do we use it? And the answer to this question is in two parts. So I'm going to say we use the sine rule. So we'll use it in two conditions. We use the sine rule either, so we'll have two conditions. So we'll use it either when we are given two angles in one side. That is when we are going to use the sine rule. Number two, we can use it when we are given two sides of a triangle and a non-included angle. I will explain what a non-included angle means. So we will use it when we have two sides and a non-included angle. So let me draw this for you so that you understand exactly when do we use this sine rule. So let's consider a sketch which I will quickly pop up. So let's have a look at this triangle A, B, C to understand what we mean by an included angle. So when we talk about an included angle, it's a situation where if I'm given the side and I'm also given the side, then what happens is the angle in between here becomes an included angle. Okay, so let me quickly label these sides. So this would be A, small letter A side, because it's opposite angle A. Small letter B, this is opposite to angle B, and C. So if I am given side, if you look carefully, the side AB and the side AC, and also I'm given angle A, then if you look carefully, it forms a V. So once we form a V, then angle A is an included angle. Okay. So angle A as it stands, it is an included angle. So another way I want you to think around this idea of included angle is think of a V. So if you have a V, once the angle is inside here, that is known, and the side on the left and the side also on the right of the angle is known, that is an included angle. And for our sine rule, we don't want to be given that. We can't use it under these conditions. Okay, we can only use it when we are given two sides and a non-included angle, meaning the angle we are given is not supposed to be inside a V where the V is made up of the two known sides. Let me give you more example of this. So just to make sure that we understand, what I'm going to do is I'm just going to quickly make a legend. So our blue here, we'll just say it's a given side. Okay, so blue will be a given side, and let's use another color. Let's use pink, and we'll say that also pink will be a given side. And we will use our purple for the angle, so that I'm going to show you the different cases where you can use the sine rule and be able to get your answers correct. So let's use the purple for just saying the angle. So it means for me to be able to use my sine rule, if let's say I'm given this side, which is blue, well, that's not the same blue. Yeah. So let's say I'm given this side A, and let's say I'm given the other one, this one. It means the angle that I need to be given must not be an included one. It must not be there to form a V. So it means I can either be given the angle there, or the angle can sit just below on angle C. That would still work because angle C is not an included angle. So if you look at these two cases, when I'm trying to determine, this would work. So this triangle is okay, this one is okay. So we can use sine rule for these. So we can do other combinations around so that we make sure that we understand. So let me just erase and consider other sides. So let's make this one to be pink. So if this side is pink and I'm given, it means for me to use sine rule, it's either this angle is going to be the one that is given, because it can't be an included angle. So my purple can't be sitting there, because once it sits there, it forms a V and that becomes an included angle. So it's either the situation is like this, or let's give it a shot and quickly move the angle, or the angle can go and sit here. It is not an included angle. And we can just make one last combination. Let me think. Yep, we can. So let's go and make one last combination so that you understand when you can use your sine rule. So here, sine rule definitely will work. Sine rule will definitely work. Let's go to another one. So if you are given a situation like this, where this is now given. So what this means is that the no-go area, we can't use the sine rule if the angle here is the one that is given because it is included. So it means the angle can either be that angle, and we'll be happy to use our sine rule, or I'm sure you can take a guess. Let's paste it here. Or that angle can be that one, or we can be given angle A. That is what the sine rule states. So now, how do we write the sine rule properly? So let's tick here. We can use the sine rule. So if you look carefully here, because we don't have the V, here we can use sine rule. Let's make some space. Yep, we can use the sine rule here. And obviously we can use the sine rule even on this one, that one, this one. In fact, all of them, because we have understood we shouldn't do any included angle. Maybe let me just dramatize this just to make sure that we fully understand this. So I'll copy this and just put it up there and make sure that you understand what we are talking about. So if I raise this and I put in the angle here, you should immediately see that this becomes an included angle. And guess what? Once it becomes an included angle, we cannot use cosine rule. We cannot use sine rule here. So we cannot use sine rule. That is very important. So next, let's go and have a look at how exactly do we use sine rule now that we know when to use it. And just to reiterate, let's go back. We will use sine rule when we have two sides, very important, and one. So when we have two angles and one side, or two sides and a non-included angle. This none here is very important, okay? So let's go now and deal with the sine rule. So let's go and deal with it. So here's our sine rule. So how do we formulate it? So with sine rule, if you look carefully, we have angles. So we have angle A, and then angle C, and angle B. So with sine rule, once we say sine of angle B, as an example, I'm going to divide it with, if you look at where B is, the side opposite B, opposite angle B, which happens to be small letter b, and equals to. So let's say I say sine of angle A. So for sine of angle A, I'm going to divide it by the side that is opposite angle A. So angle A is there. So the side opposite angle A is small letter a. That is how we formulate it. Equals to, and then let's go to angle C. So sine of angle C divided by, so I'm going to stand at angle C and divide sine of angle C by the side opposite angle C, which happens to be small letter c. So this here is very important for you to remember, because that is what our sine rule is. These ratios here are very important. So other people usually write them the other way around. So or where they put the sides at the top, like B divided by sine of angle B. That doesn't make a difference. But once you do it with this one, you must do it for all. So I'll have A divided by sine of angle A, and I will have C divided by sine of angle C. So that is how we are going to use our sine rule. So now let's jump to questions and see if we will be able to get them right. Okay, let's have a look at question 1 to demonstrate our understanding of the sine rule. So question 1 shows triangle ABC, which if you look carefully, we are required to calculate the length of AB. So if you look at where AB is, that is AB, okay? So maybe let me use green. So we're required to calculate the length of AB, and that is AB. So the first question which we need to ask is, can we, clearly this is not a right angle triangle because there's no 90 degrees. So the question is, can we use the sine rule? And the answer to this will be determined by what are we given. So maybe let's make a note of that. So if you observe carefully, we are given an angle and one side. So if you observe carefully, we are given two angles and one side. Do you remember the requirements that we need to meet, or what we need to make sure that we meet for us to use the sine rule? You either need to have two angles and one side, or two sides and an angle which is not included. So let me quickly take you back. So remember I said, when do we use the sine rule? And we said we use it when we have two angles and one side, or when we have two sides and a non-included angle. Remember, the included angle thing was the V type of thing. So we have two angles and one side. So that means we can use our sine rule. So here we are good. So we can use the sine rule. So that we now understand. So now what we need to understand is, let's establish what we are. Let's put in the sine rule in place. So let's start with sine of C. So remember, what we are looking for is AB. So what I'm going to do is I'm going to put the sides at the top. So we have side AB. So I'm going to say AB divided by, remember we always divide by sine of what is opposite that side, okay? So what is opposite sine or AB is 28 degrees. So this will be sine of 28 degrees equal to. So we will now go to another side. And let's take as an example this side. So the side we have there is 10.2. So we'll put 10.2. And this will be divided by, we need to ask ourselves, what is opposite that side? And the angle opposite that side is 134. So this means we'll have sine of 134 degrees. And this will be equal to, we can also put in the third side, okay? Let's go and put it. Let's go and put in the third side. Equal to, so if you look at the third side, it would be this one. So we have AC divided by, we need to ask ourselves, what is the angle opposite AC? The angle opposite that side is angle B. So I'll divide by sine of angle B. Okay. So now that we have this in place, we can now go ahead and start looking at what are we trying to solve for. So remember, what we are looking for is the side AB. So the other parts I do not need. I only need this portion here for me to be able to solve for AB. So if you observe carefully, we only need that portion. So AB divided by sine of 28 degrees, that is equal to 10.2 divided by sine of 134 degrees. So if you look carefully, we can cross multiply so that AB will be 10.2 divided by sine of 134 degrees multiplied by sine of 28 degrees. So remember that for us to cancel that sine of 28, maybe I should show that calculation. We need to multiply both sides by sine of 28 degrees. Okay, so let's move that a bit to there. So even on the left hand side, all what we did was to multiply by sine of 28 degrees. And then these ones will nicely cancel. So this term and this term will cancel, so that what we are left with is just AB equals 10.2 divided by sine of 134 multiplied by sine of 28 degrees. So I'm going to go and use my calculator, and if you look carefully, they said 3 significant figures. So for your level of study, we'll just take that as 3 decimal places, okay? So AB will be equal to, so I'll quickly pull up my calculator and we'll see what we get. Okay, so let's quickly punch in our calculator here. So we have 10.2 divided by, I need to make sure that my calculator is in degrees. That's correct. So divided by sine of 134 and then multiplied by sine of 28 degrees. So if you look carefully, when we round that up to 3 decimal places, it will be 6.65. If you look carefully, that 6 there is followed by a 9, so that will make it to be 7. Okay, so 65.7. So that is that. So if we just consider saying maybe 3 decimal places, okay, that will work. So that is what we end up getting, and the answer is obviously in centimeters. So I hope this does make sense and you have come to appreciate how we can apply our sine rule to our problems. So let's go and have a look at another problem. Okay, let's have a look at question 2, which requires us to calculate the length of GH. So GH is this orange side. Okay. So the question which we need to ask ourselves is, can we use our sine rule here? But the question I usually ask is, what are we given? And if you observe carefully, you will see that we're given an angle in one side. So essentially what we are given is 2 angles and one side. And if you remember, 2 angles and one side, what these correspond to, they correspond to the sine rule. So once we see 2 angles and one side, we should know that what we should use is the sine rule. Okay, 2 angles and one side. So we can now go ahead and use our sine rule. So the first thing we need to do is put our sides proportionally. So we're looking for the length of GH. So I'm going to say GH divided by. So if I'm looking at GH, I should always divide it by sine of the angle opposite GH. So it means I'm going to divide it by sine of 26 degrees. That is what should be there. Okay, and then I put in another side in proportion. So let's take this one. Maybe let's make it blue. So if I take that side, you will see that I will have 13.5, and I will divide it by the angle or sine of the angle opposite the side, which would be, if you look carefully, angle H. So this will be divided by sine of angle H. And this will be equal to, so let's put in the last one. So the last side would be HI, if you look carefully. So we have HI, and HI will be divided by, if you look at HI, which is the purple side, the angle opposite it is 73. So it will be sine of 73 degrees. Okay, that is what we have. So now the problem which we are faced with is we're looking for GH, but we don't know what the HI is. And here we are missing H. So the question is, can we find angle H? If you look at this triangle. And if you think carefully, we can easily determine angle H by using our sum of angles in a triangle. That is how we can find angle H. So if you observe carefully, angle G plus angle I and then plus angle H, these are sum of angles in a triangle, so they should equal to 180 degrees, and that is just sum of angles in a triangle. So if you observe carefully, angle G is 73, so we have 73 degrees. Angle I is 26 degrees, and we now have angle H left, which should be 180 degrees. So if you quickly do the maths, you will see that angle H will be 180 degrees minus 26 degrees minus 73 degrees. So let's just go and punch in this on our calculator and see what we obtain. So what we get is 180 minus 26 minus 73. So what we get is 81 degrees. So angle H is 81 degrees. So now we can go back and put in our equation. So GH divided by sine of 26 degrees, this will be equal to 13.5 divided by sine of sine of 81 degrees. So if you look carefully, our GH, we can make it the subject of the formula, and have 31.5 divided by sine of 81 degrees multiplied by sine of 26 degrees. So let's go ahead and punch in on our calculator and leave our answer in 3 decimal places. So what we are going to have is 13.5 divided by sine of 81 degrees multiplied by sine of 26 degrees. If you look carefully, this will be 5.992. So this will be 5.992, and the units are in meters. So that is what we have there. So here we are just going to leave that out and say 3 decimal places. Okay, that is what we have as our answer to our problem. So I hope you are getting up to speed in understanding how do we use the sine rule. Okay, let's have a look at question 3 here. And remember, the first question which we need to ask ourselves is, what are we given? And if you look at our problem, we are given a side and an angle. And my question is this an included angle? If you look carefully, no, it is not, because for an included angle, you need a side and a side, and these sides will both be given and your angle will be there. So that would be an included angle. However, when you look at our problem, we are not given that. We are given two sides and an angle which is not included, meaning that angle doesn't form part of the V. So the V would be the two sides which we are given on side by side and an angle in between. So if you look carefully, our answer here is we are given two sides and a non-included angle. And a non-included angle, all what that means in simple terms is that the angle given is not in between the two given sides. That is what we mean. So the angle given is not in between the two given sides. So we are happy because if you remember what I taught you is that when we are looking at sine rule, you will use it under two conditions: two angle in one side, or two sides and a non-included angle. So that is the case which we have here with this problem. So now next what we need to do is to put in our problem. So if you look carefully, what we are trying to solve for is x. And there's x. And if you look carefully, our x is an angle. And because I'm looking for an angle now, I'm going to put in the signs, because remember the signs, they carry the angles. So I'm going to put the signs at the top. So I'm going to say sine of angle x. This will be divided by, so when I'm standing at angle x, what is opposite? What is the opposite side to angle x? If you look carefully, it is that side. So what will happen is, let me put them first with letters. So that would be side FD. And this will be equal to, I can take any other angle. Let's take angle F. So I'll say sine of angle F. So when you look opposite angle F, what you have is the side ED equal to, so we go to the next side or angle, which will be angle D. So we'll have sine of angle D divided by, when we're standing at angle D, what is the opposite side? It is EF, like that. So now I'm going to go and put in the numbers. So if you look carefully, we have sine of x divided by the side opposite x is 6.7 equals to, if you now look at angle F, that is 97 degrees. So we'll have sine of 97 degrees divided by the side opposite that 97, which is 8.1. And this will be equal to sine of angle D, which we don't know, divided by the side opposite angle D is EF. So if I look carefully, what I'm looking for is the x. So which means it is enough for me to only focus on these two. So if I just focus on this, I will be able to solve for x, because everything is numbers except the x here. So I need to remove that 7, that 6.7, and move it to the other side. So if you just cross multiply, you'll see that Sine of x will end up being 6.7 multiplied by sine of 97 degrees divided by 8.1. And if you look carefully here, what we are trying to do is solve for x. And x happens to be an angle here. And if you remember, when you are solving for an angle, you use your shift. So x will be the shift of sine, which will give me the sign with that minus on the calculator, 7.6 times sine of 97 degrees, all divided by 8.1. So let's go ahead and find what our x is, and our problem says we should correct this to one decimal place. So let's pop our calculator and see what we obtain. So what we are going to have is the inverse of sine of, let's put it up here, 6.7. Sorry, let me try and delete that. So let's try again. The inverse of 6.7 multiplied by sine of 97 degrees and divided by 8.1. So if you look carefully, our angle is 55.18, which 18, if you round it to 1, it will just give you 0.2. So we have 55.2 degrees. That is what our angle is. So 55.2 degrees. Okay. So that is what our x is. And from here, you can go ahead and find the angle D and others. But this is what we get. Okay, let's have a look at question 4. So question 4, we are required to determine the value of A, of which A is just this side in centimeters. And we need to ask ourselves the very important question, which is, what are we given? This question helps us because once we answer it, we are immediately sure what we should use. You will see when we now do the cosine rule, how the answer to this question determines whether you use sine or cosine rule. So if you observe carefully, you're given an angle and a side. So what this means is we are given two angles and one side. And if you remember, when we have two angles and one side, you are allowed to use our cosine rule. Sorry, our sine rule, not cosine. Okay, we'll deal with cosine later. So what we are going to do is we are going to go and put the sides in proportion with the angles. So I'm going to put in side. So if you observe carefully here, let me name them. Let me call this one A, angle B, angle C, like that. So what I'm going to do is I'm going to have side AB. Side AB is opposite to angle C. So I will divide it by sine of angle C. The reason why I'm going to put the sides at the top is because I'm looking for a side, which is side AB, okay? And if you look carefully, if I put in BC, side BC, I must divide by sine of the angle opposite BC, which is angle A, equal to the side left now is AC. So when I go to AC, I will see that the opposite angle to AC would be angle B. So I'll have sine of angle B. So now I'm just going to place all the values that we have here, and just please be aware that side AB is equal to A, which is exactly what we're looking for. So where there's AB, I'm going to put in A divided by sine of what is opposite side A, which is, it will be sine of 35 degrees, equals, and then we go to BC, and BC we don't have, so I'm just going to leave it as BC divided by sine of A, and then equal to, if you look carefully, we have AC, and AC is 6.8 divided by the angle opposite AC is 64. So sine of 64 degrees. So when I look at my equal signs, the middle part here is not helping me so much. So it means what I need to do is I need to take this yellow and equate it to this one, because there is nothing missing there. So if I equate the two, I'll be able to find out what is the A value. So A divided by sine of 35 degrees equals 6.8 divided by sine of 64 degrees. So I can now go ahead and do my cross multiplication. And when we do our cross multiplication, the sign on the denominator of A will move. So we'll have A equals 6.8 divided by sine of 64 degrees, and then multiplied by sine of 35 degrees. So now we'll just go ahead and look for the value of A, and we'll see what we find. So let's pop up our calculator, the side, and if you look carefully, what we have is 6.8 divided by sine 64, and then multiplied by sine of 35. So if you observe carefully, if we just put this in 3 decimal places, this will be 4 point, if you look carefully, 3, so the 9 will end up being a 0 and then make a 4. So if you look carefully, it will be 3, 4, 4, 0, like this. So that is what we are going to have. Okay. And this is in centimeters. Let me make sure. Yep. And this, you will see that it is in centimeters. And I said, for the purposes of your study, we'll just consider 3 decimal places. Okay. So that is how you would use your sine rule to be able to solve this problem. I hope it makes sense. Okay, let's have a look at problem or question number 5, where we are required to calculate the value of x, and x happens to be the angle L. So the first question which we need to ask ourselves is, as you look at problems like these, is what are we given? Because depending on what we are given, we will determine what we will use. But for this segment, we are focusing on sine rule. So the pattern will be more the same than different. So if you look carefully, we have a side, and an angle. So what we are given is 2 sides. And if you observe, the angle is not included because the angle is not between 2 known sides, the one which we are given. So it is 2 sides and a non-included angle. And if you remember, when we have such a case, we are allowed to use sine rule in such a case. So what we are going to do is we are just quickly going to put these sides in proportion according to our sine rule. So since we're looking for the angle, it means I'm going to put the signs at the top. So I'll have sine of x divided by the side opposite x is jk. So I'll have jk equals 2. And then let's say, sine of j, sine of angle j divided by, so angle j is opposite lk. So angle j is opposite side lk. So we'll have lk equals 2. The other angle is angle k. So sine of angle k, this will be divided by, so when we look from angle k is opposite to lj. Okay, so I'm just now going to put in what we have. So you'll see that we'll have sine of x divided by jk, which we don't have, and then angle j, sine of angle j is 78. So I'll have sine of 78 divided by lk. If you observe carefully, lk is 9.2. And this will be equal to sine of k, which I don't have. And this is divided by, if you look carefully, 4.7. So if you observe carefully, the problem we have here is we don't have this jk and we're looking for x. And the only two equations that have one unknown, it is these ones. So it is this portion that has only one unknown, which happens to be angle k. Okay, so if you observe carefully, what we have there is sine of angle k divided by 4.7. This will be equal to sine of 78 divided by 9.2. So it looks like angle k is easier to find, but think about it carefully. We know that x plus angle k plus angle j, this will give us 180 degrees. This is sum of angles in a triangle. Okay, and if you observe carefully, you'll have x plus angle k plus the j is 78 equals 180, which means angle x essentially is 180 minus 78 degrees minus angle k. So which means if we find angle k, we would have found angle x. So let's go ahead and calculate angle k. So you will see that the sine, we will need to isolate it. So sine of k will cross multiply with the denominator, so that we have 4.7 multiplied by sine of 78 degrees divided by 9.2. We're looking for angle k. So if you just go to your calculator and click shift, we'll have sine arc off all of what we have above here. So let's copy it, put it here. So we'll just need to go on our calculator and put all of that and find what angle k is. So let's pop our calculator here. So if you look at our calculator, we'll just do inverse sine of 4.7 multiplied by sine of 78 divided by 9.2, close that, and what we get is 29.98 degrees. Yep, if I round it up, let me see how many decimal places. They want 1, so 2 should be okay so far. And then now I can go ahead and find what x is, because x is 180 degrees minus 78 degrees, then minus k, which happens to be 29.98. So our x will be 180 minus 78 minus 29.98. And this will become 72 point, if we make it one decimal place, it will be 0.0 degrees. Okay, let's have a look at question number 6. So on question number 6, they give you a whole story, but the main point is they're looking for the distance QS, which that is what they're looking for. And what I usually advise you to do is that you try and populate as much as you can. So for example, this angle here, the blue one, we can easily find, because the blue angle, which is, if you remember, 62 degrees plus the blue angle, which would be S angle PQ, that should be equal to 180 degrees, because those are angles on a straight line. So if you remember, angles on a straight line are supplementary. So this means that S angle PQ, which is this blue dot here, that will be 180 minus 62 degrees. And that will be, let's put it up, 180 minus 62. And if you look at our calculator, let's just pull it the side a bit. So if you look at our calculator, it becomes 118. Okay, so now let's quickly note that the angle inside that triangle is 118 degrees. And then now we need to go back to the most important question, which would be, what are we given? So if you observe carefully, we are in respect to this triangle. So maybe let me make the orange triangle. So that is the triangle we're looking at. So if you observe carefully, what we have is two angles and one side. So the side is the side PS, which is 2.9 kilometers. So what we have is two angles and one side. And if you remember carefully, this is what we require in order for us to be able to use the sine rule. So let's go ahead and quickly start formulating our problem. So if we're looking at the side QS, that side I will need to divide by what is opposite QS is angle P. So I would need to divide by sine of angle P. And this would be equal to, let me try that again, sine of angle P. So I'm just going to take another side. Let's take PS divided by, PS is opposite the angle Q. So that would be sine of angle Q. And then the next one will be PQ divided by, if you look at PQ, it is opposite angle S. So that would be sine angle S. So let's go ahead and deal with the QS. So QS will be divided by sine of angle P, which happens to be 118. So it will be divided by sine of 118 equals 2. And then PS is 2.9. So we'll have 2.9 divided by, opposite angle is angle Q, which is sine of 36 degrees. Then equal to, we have PQ, which we don't know what it is, divided by sine of angle S, which we don't know what it is. But remember, we're trying to solve for QS. So looking at this block here is sufficient, the blue one, to allow us to be able to solve for our QS. So if you observe carefully, our QS will be divided by sine 118 degrees, and this will be equal to 2.9 divided by sine of 36 degrees. So if you quickly do your cross multiplication here, you'll see that your QS will be 2.9 divided by sine of 36 degrees multiplied by sine of 118 degrees. So let's get our calculator up on our screen. Okay, so if you observe carefully, let's punch in those. So what you have is 2.9 divided by sine of 36 and then multiplied by sine of 118. So what we end up getting is our QS is, let's see, they said how many decimal places here. Well, they said 3 significant figures, so I'm just going to use 3 decimal places. But that is 4 significant figures actually. But let's do that. So 4.356, and remember, this is in kilometers. So that is the answer which we find of PQ. So I hope that does make sense and you understand how we found this answer of QS, not PQ, sorry. Okay, hope it makes sense. Thanks. Okay, let's have a look at question number 7. So on question 7, we are required to calculate the size of the obtuse angle VUW. So it is the angle which I've highlighted in green. And the first question which we need to ask ourselves is, as always, what are we given? This is useful because it helps us to establish which rule we should use. But obviously in this video, we are more focused on the sine rule. So if you observe carefully, you have a side and an angle. And this angle is not included, meaning it's not between the two given sides. So we can go ahead and state that what we have is 2 sides and a non-included angle. So that is very important. And once we have 2 sides and a non-included angle, we are allowed to use the sine rule. So let's go ahead and put in these in proportion. So since we're looking for the angle, I'm going to put the trig ratios at the top. So I'm going to have sine of u divided by what is opposite angle u is the side VW equal to, and let's go to sine of angle V, and what is opposite angle V is the side UW equal to, we have another angle, sine of W divided by, now we at angle W, the side opposite angle W is UV. So let's focus on what we are looking for, which is the U. So we'll have sine of U divided by, the side opposite angle U is 7.3 equal to, we are going to sine of V, which is 32. So that will be sine of 32 degrees divided by the side opposite 32 degrees, which if you look carefully is 5.6, and then equal to the other side, sine of W divided by the side which is opposite that is just UV. And if you observe carefully, we just only need to focus on these two. So we just need to focus on this and we will be able to find our answer. Remember, we're looking for U. So if we focus on this, we should be able to find U. So if we cross multiply, you will see that our sine of angle U will be 7.3 multiplied by what we have, which is sine of 32 degrees, divided by 5.6. And remember that we're looking for angle U. So angle U will be shift of sine, which will give you the inverse of sine, 7.3 multiplied by sine of 32 degrees divided by 5.6. So let's quickly pop up our calculator and see what we obtain. Okay, so let's go ahead. The inverse sine of 7.3 multiplied by sine 32 divided by 5.6. Close the bracket. So if you observe carefully, so if you observe carefully, the angle which we getting, let me see, is this in degrees? Yes, it is 7.3. Let me double check. The question we have is saying the angle is supposed to be an obtuse. But we're getting an acute. So it means that there is not true. So let's put it down. So our angle U, according to our calculator, is 43.6. They said, yep, let's make it 2 decimal places. So 9 degrees. And if you observe carefully, this is not an obtuse angle, isn't it? So that is rather an acute angle. So we should make sure that we do correct that. So what we have here is not obtuse. It is rather acute. Okay. Very important. So that is what our angle is. And remember that usually these diagrams are not drawn to scale. So you should be careful of that. Okay, let's have a look at question 8 next, which requires us to solve for x, of which x is that side. So we need to pose the very important question, which is, what are we given? And the answer to this, we've answered this a couple of times. You will see we have an angle, and side. So we can just say 2 angles and 1 side. And if you remember, when we specified the requirements that we need to make sure we meet for us to use the sine rule, 2 angles and 1 side was one of them. So this should be very easy to work. So let's call this A, let's call this B, and let's call this C. So if you look carefully, how I can put these in proportion is I can have the side AB. If you look at AB, it is opposite side for angle C. So I'm going to have divided by sine of angle C. And then if I go to AC, divided by, if you look at AC, it is opposite angle B. So this will be sine of angle B. And if you look at BC, it is opposite angle A. So this will be sine of angle A. So now let's go ahead and deal with the x, which is AC. So if you look at what our AC is where the x is. So I'm just going to say x divided by, so the angle opposite x would be 46.5, which means I'll have sine of 46.5 degrees equal to, so if I look at AB, it is length 7, and the angle opposite the side which has 7 is 39.4 degrees. And then the last one left, which is BC. And BC will just be divided by sine of angle A. And if you observe carefully, what is more useful here is this portion. That is what we need to work with so that we are able to solve for the x. So if you observe carefully, if I do cross multiplication, our x will end up being equal to 7 divided by sine of 39.4 multiplied by sine of 46.5 degrees. So let's go ahead and figure out what the x is. So let's move it here. Clear. Let's put up 7 divided by sine of 39.4. We double check 39.4, that's correct. And then multiplied by sine of 46.5. So if you observe carefully, our x turns out to be 7 if you look carefully, 99. So if we really want to round that off to one decimal place, that will actually become 8.0. So let me see. Yep. So let's choose this to be in meters. So this will be 8.0 meters. Okay, that is how we get the answer for x for this question. So I hope that makes sense. And you now have a good feel of how to use the sine rule. Okay, let's have a look at this second last question. And as we always ask ourselves is, what do we have? Or what are we given? So if you look at this problem, we are given two sides and an angle that is not included. So that is very easy. So what we have is two sides and a non-included angle. And that is very important. So let's go ahead and figure out what is B. So since we are looking for B, which is an angle, I'll put up the signs at the top. So it will be sine of B divided by what is opposite B is 3.6, whatever the units are, equal to, if you look carefully, we have sine of 100 degrees divided by 5.1. So if you observe carefully, you can just do cross multiplication, okay? And what you will end up having is sine of B equals 3.6 multiplied by sine of 100 degrees divided by 5.1. And if you quickly do your maths, you'll see that your B, you'll just say shift of sine, And you'll have your 3.6 multiplied by sine of 100 degrees divided by 5.1. So we can now go ahead and quickly punch in the b on our calculator and be done. So let's see what we obtain. So the inverse of sine, and what we have is 3.6 multiplying sine of 100, and this is dividing 5.1. So if you observe carefully, the angle which we get is 44. So 44 point, let's leave it at 3 decimal places. It will be 0.4. That will be compounding. Yep, it will be 0.40. And this is in degrees. So if I just choose to write it in 1 decimal place, it will just be 44.0 degrees. Okay. I hope that does make sense. So that is how we obtain that. Okay, let's have a look at this last question that requires us to solve for x. So x happens to be a side that is opposite angle C, but we don't know angle C, but we have the other two angles. So maybe the first starting point should be finding angle C. So angle C is very easy to figure out here. So if you look carefully, angle A plus angle B plus angle C, that should give you 180 degrees. And the reason here is this is sum of angles in a triangle. Okay, so let's go ahead and put them. So we'll have 40 degrees plus angle B, that is 94 degrees, plus angle C, this should be 180 degrees. So angle C we'll easily find by doing 180 minus 94 degrees and then minus 40 degrees. So angle C will be, let's quickly pull up our calculator. So we have 180, it will be 46 degrees. So now that we have our angle, we can now go ahead and start putting these in their respective sides. So we're looking for side x. So I'll have x divided by sine of the angle opposite side x, which is angle C, which is 46 degrees. And then we have another side, which is 10.5. And the side 10.5 is opposite 94 degrees. So that is all what I need, but we can put in the other one, which is, it would be the side BC. And BC is opposite 40. So that would be sine of 40 degrees. But I don't need the BC side. So all what I need is just this portion. So this portion is good enough to get me the answer. So if you quickly do your cross multiplication here, you will realize that our x will just be sine of 46 degrees multiplied by 10.5 divided by sine of 94 degrees. So let's go ahead and punch our x on our calculator and see what happens. Okay, let's make it a bit bigger and move it. So if you look carefully, what we have is sine of 46 multiplied by 10.5, not 85, but 0.5 divided by sine of 94. Okay, so if you look carefully, the answer is 7.57, whatever the units are. So that is how we get our answer for that question where we are required to solve for x. So I hope with these examples you now understand how we deal with the sine rule, and you will now be in a position to answer any question that requires you to use the sine rule. So remember, let's put in just a summary in closing. So I need you to remember this in summary. So if you remember, there's a very important question which we ask, which is when do we use so the focus now is on the sine rule. And there's two answers. A, it is when we are given two angles in one side. That is when we use the sine rule. The second one is when we have two sides and a non-included angle. And I want you to remember, when we are speaking of a non-included angle, let's say, for example, we have a side or a triangle like this. So if I'm given the pink side like this and this one, if the angle does not lie on the V, let's say the angle lies here or the angle is there, those angles are non-included. So that is very important. Let's make some space. So those two angles are non-included. And then let me give you another example. Maybe let's copy this one and put it here. And we make that. So once the angle sits on the V, where the two sides are given, that is an included angle. Okay, so another one, maybe let me take this one and this one. So if we make that and that, once the angle is here forming a V, that becomes an included angle. So with the included angle, chat, it must just form a V. If you're given the side on the left and on the right and the angle in the middle, that angle in the middle is an included angle. So that is the chat with the sine rule. I hope this does make sense and you enjoyed the lesson and you now understand what is happening. So stay tuned and make sure you check the next session, the next lesson, which is on the cosine rule. Thank you.